Hello everyone, welcome back. Today we're going to be working on lesson 1.14 and our learning target for today is I can analyze the outliers of data sets to examine its impact on mean, median, IQR, and standard deviation. So let's take a look at our vocabulary. So an outlier is the data value that is unusual, that it differs quite a bit from the other values in the data set. So in this case, we have the lower outlier boundary, which can be used by this equation. You take Q1, minus it from 1.5, and then multiply it by your IQR. Then you also have the upper outlier boundary. You take Q3, add it to 1.5, and then you multiply it with your IQR. So typically we would see if a number is either smaller than the data set that we are given or abnormally larger than the data set that is given. So let's take a look at our lesson synthesis. So a number cube has sides labels 1 through 6. After rolling 15 times, Tyler records the data, and this is basically the data that we are given. So we have to determine if there are any outliers. So judging from the data set right here, we see 1s, 2s, 3, 4, 5, all the way up to 6. But then the number 20 looks like it stands out. So 20 is a possible outlier because that number is way too large for it to be part of this data set. But let's verify that. So when you go into one variable stats, you put your numbers in L1, go into one var stats and calculate it. You want to find all of the necessary information. So what this means is that you want to find your mean. In this case, our mean is 4.2. You want to find your standard deviation, which is the fifth number. So let's say it's about 4.5. You want to find your minimum, which is 1, your Q1, lower quartile 1, which is also 1, your median, which is 3, your Q3, which is 5, and then your maximum in this case, which is 20. And also what you want to do is that you want to find IQR. So remember, IQR is when you take Q3, subtract it from Q1, and in this case that's going to give us 4. So now we're going to use the formulas to see if we have a lower outlier boundary and then an upper outlier boundary. So remember, for the upper outlier boundary, you do want to take Q1, subtract it from 1.5, and then multiply that number by your IQR. So my Q1 in this case is 1. We're going to subtract that with 1.5. Then we're going to multiply it with our IQR. So in this case, our IQR is 4. And you can just put this into the calculator exactly how you see it. And we get about -5. When we are doing our upper outlier boundary, we take Q3 and we add it with 1.5, and then we multiply that with our IQR. So Q3 in this case is 5. Then we're going to add that with 1.5, and then we're going to multiply it with our IQR, which is 4. So all you really have to do is plug that directly into the calculator exactly how you see it. So now, how do we synthesize this information, right? So any numbers within our data set that we have here, if they are smaller or less than -5, then we have a lower outlier boundary. In this case, all of the numbers in our data set are not less than -5. So that means we don't have a lower outlier boundary. Now let's take a look if we have an upper outlier boundary, which we kind of do suspect. We suspect that it is 20. So in this case, the answer that we got was 11. So any of the numbers in our data set that are greater than 11 is basically considered an upper outlier. So in this case, 20 would be our outlier. So we want to say the value 20 is the outlier. And this is because it's greater than our IQR. So, not greater than, it's basically greater than our upper outlier boundary. So in this case, we suspected it was 20. We just confirmed it by using the formula that was given. So let's take a look at part B. So would it be appropriate to keep or remove the outlier when analyzing the data? So in this case, since we are rolling a dice, let's say we're rolling dice, we know that 20 does not show up on dice unless you're using one of those fancy dice that does go up to 20. But if we're using a dice that only has 6 sides. So in this case, it would be appropriate to remove 20. So sometimes we would have to see if the outlier is either data that we can remove so that our data becomes normalized because it's either an error, or we can keep it. Maybe it's not a mistake. We would just have to think about it very clearly. So it would be appropriate to remove the outlier when analyzing the data because it's not possible to roll a 20 on a dice that is labeled 1 through 6. So what would happen if we actually remove that 20, right? How would it affect the mean, the median, the IQR, and the standard deviation? So if we do go back into stat and we do edit, we can edit our list and we can remove that 20. You just have to press delete. So then go into stat, move to the right, and then we're going to recalculate everything that we just did. So now we would just see if we do remove this outlier, how does that affect our data? So in this case, right, we do take a look at our mean. We see that the mean is decreased. Our standard deviation in this case is decreased. But everything else essentially stays the same, right? The maximum in this case also decreases too because we removed that 20. So the IQR basically stayed the same. So if we were to remove the outlier, right? Our mean, our standard deviation will decrease. But our IQR remains the same. And that's that.